Hi everyone. This is the sixth grade model and solve assignment where we are modeling and solving equations. Again, this is the sixth grade one. Seventh graders, you have one that's very similar, but this one's going to be the sixth grade one. So for modeling and solving, we are going to model each equation and then you're going to solve it. You have an option when you're solving it. You can solve it on a piece of paper or a whiteboard and then insert your picture into your slide, or you can take a screenshot of your slide, your problem, solve it on your screen, and then paste it back into your slide. So whichever one is easier for you, but you do have to make sure that you show me your work, you write it out somehow, either on the screen or writing it out on paper or whiteboard. Do not type this. It's going to be a little bit harder to show your work using typed symbols. So I want you to practice writing it to show your work. Okay. All right. So here is the first problem. X minus 3 equals 8. And when we're modeling, we just want to represent our math sentence using a picture. Okay. So using these symbols here, can we show x minus 3 equals 8? We're not solving anything yet. We're modeling first and then solving. So x. Okay, so I'm going to drag this green x because I have one x. It's positive. It doesn't say minus x. Just one positive x minus 3. A lot of people want to say we then drag 3 red negative x's, but this is not minus 3x, just minus 3. So I'm going to drag these negative ones. So x minus 1, x minus 2, x minus 3. Okay, so does everyone see this x minus 3 represented right here, x minus 3? And it equals 8. So we're going to drag positive 8 on the other side of our mat. You can drag 8, you can copy paste 8, whatever is easier for you. I'm going to copy and paste my 8 like this. But if you want to drag 8, you can drag 8 positives. So x minus 3 equals positive 8. I can see my problem is exactly the same as my model here. Okay, so this is the model for x minus 3 equals 8. Now let's move on to solving this. The way I'm going to do it is I'm going to write on my screen, but you're, again, either going to take a screenshot of this, write on the screen just like I do, and then paste it back into your slide so I can see your work, or you're writing this down on a piece of paper or whiteboard and taking a picture and inserting a picture back into your slide. But I need to see your work. Now, when we're solving equations, remember, equations are balanced. We think about a balance beam, or we're thinking of a coat hanger. We want it to stay equal. Because the important thing about an equation is that they are equal. The two sides, the left side, the right side, have the same value. They are equal. They're nice and balanced. So what you do on one side of your equal sign, you have to do on the other side. We also know that we have to use inverse operations or opposite operations to solve equations. So if I see my variable is being subtracted, so x minus 3, we're going to do the opposite of minus, which is addition. If you see x plus 3, we're going to do the opposite of addition, which goes back to subtraction. Okay, so whatever's happening to your variable. This 8 is on the other side. It's just minding its own business, so don't worry about that 8. But what is happening to your variable? Okay. When we're solving these one-step equations for this entire assignment, I know a lot of you guys are really good at reasoning. You can ask yourself, what minus 3 is 8? You can kind of guess and check a little bit. 7 minus 3 is that's only 4. 10 minus 3, 7. Oh, it must be 11. 11 minus 3 is 8. Okay, so that's easy to see and easy to determine our answer just by kind of guessing and checking in our head and thinking, 11 minus 3 is 8. But later on, you're going to be given much more complicated equations. So we are practicing showing all of our work for these simpler equations, ones that you can probably figure out without doing all your work, so that when you get a tough one later, you're going to be able to solve it, showing your work. Okay? All right, so first thing, we want to draw a line down our equal sign. So I'm going to go ahead and erase this. We're going to draw our line down our equal sign because this represents the two sides of our balance beam. I'm going to highlight my variable x because at the end, after I show all my work, I want it to say x equals this number. We're trying to figure out what does x equal. Okay. So now let's figure out what's happening to your variable. My x minus 3. 3 is getting subtracted from x. So we have to use opposite operations. What's the opposite of subtraction? Addition. So instead of -3, I'm going to add 3 to both sides. I'm going to change colors here, but you can keep writing in the same color. Just changing colors so you can see a little bit clearly. But if I add 3 to one side of my balance beam, it's not going to be even anymore, right? If I added 3 pounds, for example, to this side, it's going to tip over. It's not going to be balanced. So I also have to add 3 to this right side to keep it balanced again. -3 plus 3 is 0, and this is why we do the opposite operations, because we want this to essentially go away so that on our left side we have just x. Okay, and x is 8 plus 3. What's 8 plus 3? 11. And we can always check our work and see if it makes sense. Is 11 minus 3 8? 11 minus 3 is 8. So this is how you show your work. Make sure you show all your work. Don't just write x minus 3 or x equals 11. You're not going to get credit for it. So make sure you show all your work, just like I did. Copy down my work and then paste it back into your slide. Make sure you're writing this on your own. I'm going to be able to tell if you use my work. Number 2, first we're going to model x minus 4. This is very similar to our x minus 3. Still positive x. This time we're going to have 4 negatives. So x minus 1, minus 2, minus 3, and minus 4. And it equals a positive 3. So we're going to use these positive 3 counters. X minus 4 equals 3. All right, now we're going to go ahead and solve this. Start by drawing a line down your equal sign to help show you the two sides of your equation, your two sides of your balance beam. I'm going to highlight my variable so I know that's what I'm supposed to look out for. What is happening to your variable? X minus 4. So what is the opposite of minus 4? Plus 4. Okay, again, you can probably figure this out. One number minus 4 is 3. We're working on showing our work so that we don't have to guess and check. I'm going to add 4 to both sides. Plus 4, plus 4. Negative 4 plus 4, that's 0. So I'm just left with this x over here. 3 plus 4 is 7. All right, x equals 7. 7 minus 4 is 3. Does that make sense? Is 7 minus 4 3? Yes. So that is correct. Okay. So again, you're looking to see what's happening to your variable, what's happening to your letter. If you see addition, you're going to subtract to solve it. If you see subtraction, you're going to add to solve it. Okay, I'm going to keep going. Pause this video if you need to. Model negative x plus 7 equals negative 2. This time we have this negative x, so we're going to use this red x block. Plus 7, positive 7. I'm going to drag over the 1. You can copy and paste if you like. 1, 2, 3, 4, 5, 6, 7. And it equals a negative 2. Negative 1, negative 2. Okay, now let's solve this. Draw your line down your equal sign. I'm going to highlight my variable x. This time x is negative, and I'll show you what to do about that once we get to the end. What is happening to your variable? I've got negative x plus 7. We're going to use inverse operations or opposite operations to solve. So what's the opposite of plus 7? Minus 7. So let's subtract 7 from both sides. Positive 7 minus 7 is 0. So we are left with negative x. What is negative 2 minus 7? This is really tricky for a lot of you guys. Think about a number line. If we're at negative 2 and we subtract 7 more, you're getting even more negative, right? So negative 2 minus 7 more jumps. We're getting further away from 0. Negative 9. Okay, when we're solving equations, I want to know what positive x is. Not negative x, positive x. But we can figure this out. If negative x is negative 9, positive x is positive 9. Okay, so if your variable is negative, we just need to flip your sign. Negative x is negative 9. Well, that must mean positive x is positive 9. Okay? And we can see if this makes sense. If we have, let's see, negative x, so negative 9. Negative 9 plus 7 is that negative 2. This is how you check your work. If you need to draw a number line, draw a number line. If you're at negative 9 and you go up 7, you're getting closer to 0, but not quite. Not quite there yet. Negative 2. So this is correct. Okay. Next. Positive 10 equals x plus 6. This time we have our x on the right. That's okay. Doesn't matter because we know both sides are equal. So go ahead and drag your positive 10 ones. I'm going to copy and paste groups of 2. 2, 4, 6, 8, 10. Equals a positive x plus 6. Plus 6. Okay, so we just need 6 ones. 1, 2, 3, 4, 5, 6. You can spread out your pieces if you like, as long as I can see a positive 10 equals positive x plus 6. Okay, let's solve. We're going to solve the same way every time. Draw your line down your equal sign. I'm going to highlight my variable. Your variable's on the right this time. So we're not worried about the x. We want to see what is happening to your variable. Okay, so we're not worried. Did I say we're not worried about the x? We're not worried about this 10. Okay, we're not worried about this 10. We're not doing the opposite of 10. We want to do the opposite of what's happening to your letter. Okay, so I see x plus 6. What is the opposite? What is the inverse operation of plus 6? Minus 6. So we're going to subtract 6 from both sides. Positive 6 minus 6 is 0. So we have x over here on the right. That's okay. X equals 10 minus 6 is 4. Okay, if we're not used to seeing x on the right side, you can rewrite it. That means x is 4. Let's check our work to see if that makes sense. Change colors here. 10, does 10 equal 4 plus 6? Yeah, 4 plus 6 is 10. Correct. Our next one, positive 2. 1, 2. Equals negative 3. This time we're using these negative counters. Negative 1, negative 2, negative 3, and a negative x. So negative 3 and a negative x. Just so you guys know, when you see this plus minus right here, you see this plus a negative, something like that, this is the same thing as 2 equals negative 3 minus x. You actually don't need this plus. This plus kind of acts as the word and. You have negative 3 and you have a negative x, which is the same thing as negative 3 minus x. Okay, I don't know if that helps some of you guys think of these problems. All right, let's solve this. Draw your line. Highlight your variable, if you can. And this is a negative x, so we're going to solve this, and then at the end, we're going to flip it to get positive x. All right, this 2 is just minding its business. Don't worry about that 2. What is on the same side as your variable? I see this negative 3 that we have to get rid of. Okay, don't think about this plus sign. This is just the word and. We have to get rid of this negative 3. So what is the opposite of a negative 3? Or if you want to think of it as minus 3, same thing. What's the opposite? Plus 3. So we're going to add 3 over here. Add 3 over here. Negative 3 plus 3, 0. So we are left with this negative x. Okay, we're going to pull that negative x down. 2 plus 3 is 5. Now let's think about this. We want a positive variable. If negative x is positive 5, then positive x is negative 5. So if you see that negative x, we're just flipping the sign of the answer. Okay, if negative x is 5, what is the opposite? Positive x is negative 5. So here's your answer. You can rewrite it. If you want to put x first, you can. X equals -5. And then we can check our work. 2 equals -3 plus let's see, negative x is +5. -2 equals -3 plus 5. Is that correct? If you're at -3 on the number line and you go up 5, you're going to go past 0 up to +2. So this is correct. Okay, so always check your work. We check our work by plugging in your answer back into the original equation. All right, and that was it. Okay, I really hope that you tried this on your own and then you checked your work. If you got stuck, you watched this video. I hope this video helped. See you guys.